Hello all, let us see how to enable RTC in MSP432 microcontroller. So if you see the reference manual of MSP432 microcontroller, you see there are few registers which are important and which need to be configured. So if you talk in brief, the first thing what we have to do for RTC is enabling the RTC, configuring the hours, minutes and seconds registers, and then starting the RTC so that the seconds increment and accordingly the minutes and hours gets incremented. So it's very easy to use. If you see the main registers that are associated are RTC control 0. So this control 0 has lower byte and the higher byte. So if we just go to that, this is the lower byte where the interrupt related bits are present. There is higher byte where if you write A5H, you can unlock the RTC registers, specifically the RTC module, and if you write 0 to this or anything other than A5, the RTC would be locked. So this is called a real-time clock key. So the main thing what we have to do here is basically write this A5 to RTC key bits, and which is part of RTC CL0. So if you go to the program, so as a part of configuring the RTC, the first thing is writing that RTC key underscore H, which is nothing but here it is A5, and then RTC 0 control L. So this is nothing but enabling the interrupt. So if we go back, this is interrupt enable, and there is one more flag called interrupt flag. So if you want to enable this and this, that means you want to know the interrupts, you just enable them. Otherwise, if you want the RTC to run in the background and you do not want to have any interrupts, you can ignore them. So the first thing is writing A5, and second thing, there is one more register called RTC control 1, which is very important with respect to enabling or disabling the RTC. So if you go back here, this is the RTC control 1. If you go here, there is something called RTC hold. So RTC hold, if you include 0, real-time clock is operational. If you set RTC hold bit as 1, the calendar would be stopped, and basically you cannot have the RTC running. So and then you can enable RTC in either hexadecimal mode or BCD mode based on your requirement. So here in our code we have enabled the BCD format. Now the next thing, as we said, if we just go back to the registers here, there are other registers like for date, day, month, year. So you can set these to your requirement. Like example, if you start your if you want to start your RTC from now, so you have to start it from the beginning. So there are two things here. If you see the MSP432 evaluation board, right now we are working on MSP432 evaluation board. MSP432 evaluation board doesn't have a RTC crystal, so you need to have a small additional circuit to enable that. But it has the board has RTC crystal. Basically it doesn't have the RTC battery. Sorry, it doesn't have the RTC battery. So if you want to save the time that has been run by the RTC internally, when you power off, you require the RTC battery. So a small additional circuit need to be added if required, and then anywhere 32.768 kilohertz that is being generated by the crystal, that is always there, which enables the RTC to run, and which is the default clock for the crystal. So considering that scenario, as there is no RTC battery, if you power off this entire evolution board, again as the controller starts execution from the main, it again comes to these default numbers, and then the seconds start incrementing again. So if you have a battery, even though you power off, so whatever the incrementation that has happened previously would start from there. So there are two ways here. One is you can just print whatever is required over serial port, or you can have some small 2x16 LCD or character basically, and then you can have a bigger TFT LCD kind of thing and also display. So there are several things there. But again, considering the TFT LCD, you need to write your own driver for the parallel bus, and it's a big thing. So you can use a simple 2x16 display and print these characters for your reference. So once year, then month, day, the day of the week, and then RTCR, and then minutes, seconds, all these are loaded to default values, whatever the value you want. Suppose if you want the board to start now, give the current values, and then this initially we have put it to hold condition. If you see here, we have put it to hold condition. Now we are disabling this hold such that the calendar mode would start post all the initialization that has happened with respect to the registers, and then log the registers. So if you put it to 0 instead of A5, which we have written initially, the RTC registers get logged. So these are all the initializations that happen. So now what we are doing is we are just trying to see whether the RTC has been enabled and running or not. So what we are doing is we are just printing out RTC SCC, RTC minutes, RTC hours, and separated by 0D in between and some random delay, okay, to just see that everything is happening internally or not. Whatever the increment that is happening, we are just trying to print. So if you power up the board with the same code being dumped, that's what I am trying to do now, and then go to the serial port. You can see here, so the first thing is seconds, D, and then minutes, D, hours. So this is the format that we are trying to print, and that's what you are seeing here. So slowly from 14 it goes to 16 and 17, 21. You can see here it has gone to 41, 43, 44, 45, 46, 47, 48. So the seconds are slowly incrementing. Once the seconds reach 59, if you see here 54, 55, 56, 57, 58, 59, you can see that the minutes get incremented. So previously the minutes were 10. Now you see that the minutes got incremented to 11 as we point here. So I'm just trying to stop. You can see here previously minutes was 10. The hours was 17. Now once the minutes, the seconds reached 59, still here you can see minutes are 10. Once 59 is crossed and 60 went up, you can see the minutes came to 11, and again the seconds start from 0, it go up to 59. So that's how the print happens. So we are just using a simple serial port to print this. As per your application requirement, you can modify and see how it is going. This simple configuration should work for you. So if you want, you can run it for a longer time to see whether the hours are incrementing or not, and it goes to the next day or not. So a nice an enjoyable interface to work definitely in microcontrollers. So if you have RTC coin cell, it's more enjoyable to see how it is internally running, and then fix the time, display it over LCD. There are many experiments you can do if you are a hobbyist. The list goes endless. You can add whatever you want. Hope this has helped you. Please let us know if you have any comments. If you are struggling with respect to this interface, please let us know. Please like our video, subscribe to our channel, keep visiting our channel. Thank you.